Today's a special day here at Brixworth because we've passed off the last V8 race engine. The process of passing off a V8 race engine ready to go to the circuit is very involved. There are lots of checks done in the build area before sending the engine down to the dyno area, where we bolt the engine on and check the engine thoroughly before running it. And then we do what we call a BIPO, which is a break-in and pass off. So the initial break-in part runs in the plain bearings and the rolling element bearings, and just generally gets all the moving parts working well together. And then the pass-off process is checking whether the performance of the engine and the efficiency of the engine is at the level that we expect and that we demand before we say that an engine's okay to go to the circuit and to race. The process is very thorough and has evolved over time with learning. The team of people that do it are hugely enthusiastic, hugely dedicated, very professional bunch of people. So right down to this last one, there's been a real determination only to get better and better. Engine 73 is the last engine. No particular reason for number 73, other than it's just the next sequence in this year's generation of V8 engine. Just describing the V8 engine, it's a 2.4 litre engine with 8 cylinders arranged in a V configuration. So 4 cylinders down the left-hand bank, 4 cylinders down the right-hand bank. The pass-off of this engine does mark the end of the era for us producing these engines. The mood here is mixed. I think there's a huge amount of pride in terms of what's been produced over the last years, but there's also a huge amount of determination that right down to the engines being turned off at the last Grand Prix and everything being checked out as okay. And the last results coming out, then nobody's going to relax. Everybody's going to make sure that we keep pushing hard and capture every single millisecond and ensure that every single lap is completed successfully. The dedication and the enthusiasm of the people here does mean that it's more than an inanimate object. It's a product. The V8 and the KER system is something that's very dear to us all. It's something that we've all worked very hard over, and there is going to be an element of sadness, an element of emotional attachment to it, and so that does, that does infect people. The very first V8 engine was fired up in 2005, the very first development engine. And since then, it's probably over 1,000 engines that have been built and tested. In terms of how successful have we been with that, then there have been 46 Grand Prix wins, 48 pole positions, and over 3,000 World Championship points achieved by those engines. Just to provide a bit of detail behind the V8 engine, it's a 2.4 litre capacity engine. It's naturally aspirated. So it's quite a small capacity engine, but it's revving at 18,000 RPM and produces over 750 brake horsepower. There are over 3,000 parts that go into making up each engine. I think when you look at the performance level that's achieved, from a 2.4 litre capacity engine achieving over 750 brake horsepower, a 2.5 litre general road car engine will typically produce only about 200 brake horsepower. So, well over 3 times the specific power output, and the weight is considerably less as well. And the RPM of the engine, 18,000 RPM. If you look at the rev counter in your road car, then you're lucky if you see 7,000 RPM. So just imagine 18,000 RPM. And we typically warm the engines up at 7,000 RPM before doing that pass off on the dyno. The drive to change it has come from the FIA, but working with the engine manufacturers, the existing ones, and also potential future engine manufacturers. And it's a drive to to change the focus of the technology within the engine. Today's naturally aspirated engine, we get the power out of it by revving it at very high speed. And there's no real regard for fuel consumption. During qualifying, it doesn't matter how much fuel we use. During the race, our only concern is the starting weight of the car. But for a real high performance lap, we don't really regard the amount of fuel consumed as a consideration. And that means the technology doesn't really bear any resemblance to what's going on in the road car world. And with a frozen set of regulations, there's no encouragement for new manufacturers to come in. So the FIA have put together a set of new regulations where fuel quantity and the rate with which that fuel is used are the key parameters. And that drives a set of regulations where performance is achieved through good conversion efficiency. And good conversion efficiency is what the whole road car industry is concerned with regard to CO2 emissions, and also, you know, how far can you go on a tank of fuel? It's very important to every single consumer. The key difference are the technologies that are being introduced for next year. So we're downsizing. We're going down to a 1.6 litre engine and down to 6 cylinders instead of 8 to match that capacity. We're down speeding a little bit, so going from 18,000 max down to 15,000 max RPM. But there's new technologies coming in as well, so turbocharged. So we'll boost the engine to get the specific power output and increase the conversion efficiency using waste energy that would normally just go out the tailpipe of the exhaust system, and introducing an additional electric machine into the system. So within the turbocharger, there'll be electric machine which can be used to eliminate turbo lag, which was a common feature in the 80s when we last had turbocharged engines, but can also be used to harvest any waste energy from the exhaust system. So some very interesting technologies coming in for next year. There's a lot of excitement in this building as a consequence of the new regulations, but it's a huge challenge. Developing this new technology, and also the regulations have been changed such that it's only 5 power units per driver per championship. So that's not just the internal combustion engine, but also the battery to go with the air system and the electric motors and the turbochargers. Getting the reliability to a level such that a driver can do the championship with just 5 is a huge challenge. So the performance and the reliability bring with it some big hurdles, and people are knocking those down one by one at the moment. The engine's been in development for the last couple of years since the regulations were released, and we've been progressively working through our development plan, and now working with the teams to make sure that we've got a good installation to go racing come March next year. I think the new engine will change things a little bit. It's introducing something new. The V8s and the KERS system have been very stable for several years. And so introducing something new, there's always the opportunity to learn a little bit in the opening races as to how best to apply it, how best to use it for grid position and race position at the end. And also there's the risk that with new things that things could go wrong. So we might see more failures from the power unit compared with current. Working hand in hand with Mercedes-AMG Petronas brings with it some big advantages. We've been working closely with them for the last 2 years to make sure that what we develop ideally matches in with the requirements for a fast overall race car. So the design, the concept, and the development work has been done directly in conjunction with the team of engineers at Brackley to make sure that we've got the fastest overall race car.